today we'll be talking about data collection and scraping. So before any data science project you do, definitely you have to have your data in place, whether it's structured data or unstructured data. Structured data, I mean data in tables, kind of format, and unstructured data, things like pictures and sounds. That so definitely first thing you have to do, you have to collect your data before you even start the whole workflow of a data science project. So that's what we're going to do today. So the outline for the class is data collection process, common data science, data formats and handling, regular expression and parsing. You can see the next slide, right?
Yeah.
Yes.
Okay, thank you very much. Like I said, the first step of a data science project is to get the data. So there are typically 4 ways of getting data. We have direct download a file manually. For example, if you're working with maybe working on a data science project, maybe or competition on Cargo or Zindi, for example, you download the data file and start working. Like most times, like that's what we do when we start off. Like you just download the file, or someone gives you the file from the flash drive or something. So this direct download of the file. So most times you download CSV, different file formats. So another way we can get data is querying data from database, where you use things like SQL to query the data you need and work with it. Also, we have querying an API. We'll get to talk about this, and scraping data from a waste page. So we'll be focusing majorly on 3 and 4, which is querying data from an API and scraping data from a web page. Okay. So I believe you guys have gone through the videos and stuff. So I'm just trying to explain some concepts that might not be very clear. So first off, when you want to get this data from the internet, from the web page, because querying and scraping are basically web-based data that you want to get from the web. So first step, like you have to ask yourself questions like, okay, what are the ethical ways of doing stuff like this? Because we all know how ethics in data science field is gaining a lot of ground. So there are some websites that don't want you to scrape. They provide APIs, and there are some that they don't mind if you scrape, because like scraping, you're just taking data from someone's what's it called, website and stuff like that. And sometimes it's not really ideal for you to scrape data and make it commercial, because that's someone else's work. So a quick if I scrape data, I first of all try to look at the ethics, because most times when you're pushing stuff like this, maybe you're trying to write a paper or you're trying to use the data for a solution, definitely your reporting, you have to put the ethics that was behind what you are doing. So one way to check this, for example, let's check, okay, let's just check Microsoft.com. So this is Microsoft.com. So this is a web page that we can scrape. So one way you can know what the site allows you to scrape is by adding the route called robots.tx. Can you see my screen?
Yes.
Yep.
Okay.
Yes.
So like if you do this robot.tx, you have a text file that shows you what the website, the owner of the website, allows you to scrape and what is disallowed. So you can see this. So various websites that puts this for you to know what to scrape. So with this, you know what you're allowed to scrape and what you're disallowed to scrape. So it's just like one way if you want to make your workflow ethical, because definitely you want to do a project and people start suing you to court and telling you that why did you do this, why did you do that. it's very good idea that you follow a very good process. You can check other. I'm trying to move this Zoom icon out for me. Okay. So you can check other websites. Let's say Medium. Let's see medium.com. You can check what they allow us to script. So you can see their own is not much. They just told us we can script profile stream responses and stuff like that. So this just to give you a quick heads up about ethical ways of doing this stuff. So let's move back to the slide. So from the slide, you see most data query from the web uses HTTP or HTTPS protocols to query. So you can read a lot about that. That's how like the server and clients, how they transfer data. So there's a Python library, use an inbuilt Python library that helps us make this request from this client and server pipeline to get this data. So it's called request library. You don't have to pip install it. It's already it's a Python inbuilt library. So I would like to open up a notebook here so we can just play around these things and see what they really are. So I'll try to open my terminal now. CD documents. Okay. Okay. So we could just play around this. So like this first slide shows us that we're trying to get a response. We try to get a response from a web page. So when you're using this request library, you should be online because you're trying to get data from the internet from a web page. So you have to be connected to the internet. So we import the library, and okay, let's say for example we want to get data from AI Saturday's website. I think this is it. Yeah. So this is it. You guys can see, right? Hello? Can you guys see my screen?
Yes.
Yeah.
Okay, so this is AI Saturday's website. As you can see, there are so many text data here from our mission to our goals to our core values, the organizers, their pictures. This is all data. So maybe let's say you want to you're trying to write a piece of maybe or try to prepare a dashboard and want to get the organizers of let's say AI Saturdays, and we know that maybe they change it often. I would want to be going there every day to be checking and be screenshotting or something. You want to just get something like that, or maybe the text. So this is one of the importance of web scraping. You get, so maybe you want to be getting information, request information that you know that changes often. So we'll just copy the link. Copy the link and say response response equals to requests. Okay, so we have gotten the response we need. So if you look at the slide, we have what we call status code. We have headers, we have content. So when you this status code is like telling you the how if it's successful, if you requested the data you wanted successfully, or for example, you can see maybe you're aware of errors like 404, page not found, stuff like that. Those are status code. So if you successfully requested the data and it got in, it's supposed to be 200. That shows that it was successful. So this was successful. If I tried this without my internet, would have seen I would have gotten some issues and stuff like that. So this, you can read more about status code and stuff like that. And also in every web page that you see, there are three functions, or three forces at work. We have what we call the HTML. For basic websites, we have what we call the HTML, we have what we call CSS, and we have what we call JavaScript. HTML is the content of the website. CSS is how we want to make the content look like, from fonts to colors, and JavaScript is what makes the website interactive. So when we're doing web scraping, definitely what we want to get is the content. So definitely we want the HTML file. So when you do response.content, you get the HTML file dot contents. I didn't spell it correctly. Response. Okay, response to contents, right?
I don't think there's an S. There's no S.
Okay, yeah, there's no S. Okay. So this is the like you can see docstring HTML. So these all the HTML like of that page. So both the colors, how it was aligned and stuff like this might get really overwhelming and looking at it. So this is why we need to pass, like we'll see subsequently, why we need to pass this our response into certain libraries, which we'll later discuss, to help us make this look better and to make meaning out of it and extract what we want. So with that in place, you can see here they used datasciencecourse.org. They got the content, they got the status code and stuff like that. So with that in place, you can get this data into your system. And if you
Sorry, let me add.
Okay.
Sorry. So go up a bit. No, in the notebook. So when you see sorry about the beep, sorry. So but when you see header content type, the content type gives you an idea of what you're receiving from the GET requests, right? If you run that header and then you check the content type of the request, if it's a HTML, that is the content, it invariably means that whatever formatting you'll be doing will be skewed to HTML. It could be JSON, it could be XML. So it's also important to know what the content type is. Yeah.
Okay. We could check. Let's just check that here also. So let's know what we're working with. So response dot headers, right?
There's an S, I think. I think there's an S. I'm not sure.
Okay. Okay. Yeah, there's an S. Headers contents type. Right. These things are case sensitive. Okay. Yeah. So there's an HTML file. This helps you to know what you're working with. That's also good to also add it. And also, if so, just trying to make us understand most URLs that we work with, because we're trying to get that data between the clients and transfer. So definitely, you need to understand like the meaning of some of those things that you see during when you're trying to get those URL to your system. So they said that the URLs are made up of parameters. So we can take a look at okay. So they say they're made up of parameters, and we also have some common methods such as get. You saw I used get, post, delete, and stuff like that. So these are quite easy, and you get to understand it when you're really working with like websites and stuff like that. For example, if you're using get, you're not trying to put security in place in terms of like when you open the web page, maybe you put in the data, it's going to just add up to the parameters, stuff like that. But when you're using post, for example, post tends to hide those sensitive things try to hide those sensitive things. For example, if you're trying to build up a form, you like on a web page, you definitely use a post because you don't want the name, email, password, and stuff like that to be on the website. But when you're just trying to do things like about us, information, homepage, stuff like that, things that you know that there's no sensitive things, definitely you can use those you can use get. So you can read more about those protocols extensions. We also have post, we also have put, we have delete, and stuff like that. So
Okay. So let me go a bit deeper. Yeah.
Okay.
So so most times when you use put, most times where you see put and delete being used is maybe when majorly software engineering, right? So for put, it invariably means you want to insert something into the database, right? Or you want to replace something that's in the database. That's where you see that's where you use put when you want to replace a content in a row on the database, right? Post, like Brain has correctly said, it's a more secure way of sending parameters to your endpoint. Yeah. So, or for post requests, you won't you won't have the parameters, you won't have them on the URL, unlike get. So when you're making a get request, what you'll notice is that each of the parameters that you are sending to your endpoint or to your API would always be on the URL, but with post, you don't have that. Then for delete, it just means that you want to delete something. For get requests also, it is not all the time that you want to send something to the database. You can just use a get. You might decide not to send any parameter, and then your get request just sends you a list of details. An example of a web page that uses a get is your normal Google search, right? So Brain, try and do a search on, say, search for anything on Google, right?
Okay.
So now notice that what you're sending to their endpoints in quotes is AI Saturdays. Now, if you check the URL, you'd see it is http google.com /search. So now in that search, it is that search page on Google is waiting for some parameters, right? The parameters is waiting for is what is the query? What are you querying? The parameter name is what? Q. So if you check, each of the parameters are separated by an ampersand, right? So now the first is channel is equal to crow2, and the second parameter is client is equal to fox-b-d, and the query is equal to what? AI Saturdays. Do you understand? So now if you remove all the parameters and you have just search, remove all the parameters and just leave the search. So it does remove the question mark. The question mark is the beginning of all the parameters. Remove the question mark. Remove the question mark also and search. You see, it takes you back to your home page because there's no parameter. So, but by the time you put the parameters back, it makes that the get request to Google's endpoint and then shows you a list that contains your search, that is for your search. I guess we are clear. So now, yeah. Okay, you can continue, Brain.
Thanks for that. So those, like you said, those are very various endpoints, and they have their uses. So another way which we could get data, like I mentioned, that some websites don't want you to come and strip their data. I don't know if this thing is obstructing the view. This Zoom stuff. Okay. Trying to remove it. Obstruct. Okay. There's some website that there's some website that don't want you to script their their web pages because of maybe they don't want you to just, for example, like I said, imagine maybe someone on Medium accounts, your article, someone just come and scripts it and go and write his own. That could lead to spam plagiarism or something like that. So some websites prevent that. So they have what we call APIs. Like there are some certain data that they want people to be able to use they push that as APIs. Like you just access the APIs and get that data. Sometimes, most times is in JSON format, which we'll get to talk later. So there's just like an alternative. Most websites are also going to APIs and stuff like that. So okay, so this is an example. We're trying to query a user's profile from GitHub. I don't know how many of us are on GitHub, but we could just try a simple example, because this one also needs your token, which you get from your GitHub account. So we could just try one that is free. Yeah. So I don't know how many of us have watched Star Wars. Hello?
No, I haven't.
We don't know. Me, I don't
Yes, I
know.
have severally.
Okay. I'll do two examples to show this. I think I can do two examples. Okay, so let's try. This is like this is Star Wars API. So you try to get information about Star Wars via the API. So an API is just simply an application and programming interface. What it simply does is trying to interface to softwares. For example, this software, and you want to maybe get data from this to your software you're trying to develop. So instead of you going to scrape, you just use the API to transfer that data, which is quite simple. I don't know if you get me. So that's why they just created API. So instead of you passing the whole HTML files and working this one, you can just use use the API you want and send it to your software that you're developing. So let's try this. Let's try people. So this will give us like a cast. Okay, so let's come here /API/people. Okay, so you can see this shows us count like there are 82 people. It shows us Luke Skywalker. I don't know if anyone knows Luke Skywalker, his height, his mass, and stuff like that. These are just giving us data. So just check Luke Skywalker, maybe face is familiar or something. This guy here. So we are using the API to get data, his skin color, stuff like that, his name, this is another person's name, seed, this and that and that. So this is just one way of doing this. Yeah, so you can see they are giving us all the data we want. And if you can look at the format, it's curly braces, pair values, a key, a value, a key, a value, key, a value, a key, a value. So this format you're seeing right here is a JSON format. This is how JSON files are. This is a JSON format. Okay, let's try another example. Okay, Facebook, yes, that's this. Facebook. Okay. Yeah. So this, I think this is AI Saturdays. Yeah. So Facebook uses what we call graph APIs, and could access their API should do something like graph. What's happening? Okay, I'm not connected to my Facebook. This was supposed to give us the JSON file, like it says access token is required to replace this stuff. Okay, and this is just an example, but I have to log into my Facebook account to do this, and sadly I'm not on Facebook, so I can't access this. So with this, you can get the data on that screen, the name, stuff like that. Maybe you could try that also. Just replace www with graph. So that will be able to, you are able to access their Graph API for Facebook to get data. So rather than going to say you want to script the whole of Facebook and stuff like that, you could use the API to get data you need. So that's an alternative to scripting. So like I said, basic authentication. So most of them, like this Facebook one I saw, needs authentication. It needs a form of what's it called, access token. So which definitely, if I was logged in, it would be open because I already put in my password and stuff. So so there are ones that don't need that, and there are some that need to. So with that, you could use the request has an auth method, which helps you to put in your, for example, your username and your password. But they said there are some new ways of doing this, because for example, this now your password and username might be revealed in your stuff. So most times, if you want to do this, you could use what we call environment variables. So you create your .m files and put in your password and emails. So when you're maybe sharing your code, people won't see your password and stuff just on your notebook or something like that. So you could use the environment file. You can also use auth. So you could also look that also. So she also learn how to Google all this stuff. You Google a lot as a programmer. You Google a lot. You run into errors. You Google a lot. So you can check that out. But I wouldn't tell you to always put your password and emails, usernames on your notebooks or scripts. It's not very good, because when you're sharing, someone can really access that. So I don't know if Kenichi wants to add anything to this before we move further, or if there's any question.
Okay, I think questions first. Are there any questions?
Yeah, sorry, I have a question. So the token stuff you mentioned, so that means there are some sites that needs me to supply my access token before I can access their API, access script, whatever I want to script from the outside, like GitHub on the example on the slide we have. So how do I get that token?
Okay.
Okay. So for GitHub, yeah. Okay, Brin, go ahead.
Okay. For example,
Yes.
like the Facebook one we did, the token that they needed was definitely your password and what's it called, your username. Definitely, they don't want someone that is not on Facebook to come and get data from their platform. So GitHub, for example, also has a definite, like a different GitHub. When if you look at the example about getting started with it, you have to go to your GitHub, then you have to create an access token. Like get your own access token here. So rather than putting your username and password, they just have like an access token. So definitely, for you to have it, you have to be logged in. So just like trying to, instead of you putting your password and username, they have that token. So for you to log in, for you to get a token, you have to log in. So they already know that you know your username and password to get that token. So different platforms have different authentication system. For example, if you I was working on Twilio API to send emails and stuff like that. They have what they call secret key. So those ones, like that's their own access. You have to create a username, and you have to be a user to use their platform. And when you're a user, they have like a unique secret key. So so that's how it works. Maybe Kenichi will add definitely will add to this.
So it's just
We can't hear you clearly. We can't hear you.
hello. Can you hear me?
Yeah, we can hear you now.
Okay. So I said the idea of endpoints APIs is to be able to collect and send information to whoever is requesting. Whoever is requesting might be you and I, maybe using an application like, say, Postman. So Postman is an application that you can use to query endpoints. You can also use Python. It could also be a website that you have built to constantly pull data from an API, right? Or some of the contents of this endpoints it might not be nice to just leave it open to everyone to access, because one, it means that if the API contains sensitive contents, right? It means anyone can access that content. So there must be some form of security around it, some form of restriction, you understand? And that's the idea of endpoint. So it's most of the times on these websites like Facebook, GitHub, you would have to be a user in that platform for you to maybe create your own safe access token, or for you to be able to pull some data using your username and password, depending on the way they have defined their the access to the endpoints, right? Most sometimes it could also be say a partnership between Access Bank and MTN, right? Access Bank wants to be able to sell recharge cards, wants to be able to load airtime to people's phones, to people's MTN lines, right? Their customers' MTN lines through maybe their mobile banking app or USSD. But how is Access Bank able to do this? It's through some form of API connection or API integration between Access Bank and MTN. It is not like MTN came to sit down inside Access Bank. No. Or MTN now has an office in Access Bank. No, it is MTN, it's Access Bank connecting to MTN's APIs, send some details, maybe the person's phone number and some other details, sends it to MTN. MTN recharges the person's phone and sends back a response that, okay, I have recharged this person's phone, sends it back to Access Bank. Access Bank then tells the person that, Alpha, we've recharged your phone. You can check your phone. The MTN also says, we've also recharged your phone. You get that kind of thing. So for that kind of connection, Access Bank doesn't really need to have an account with MTN. Yeah, all they just need is for MTN to create an access token for them from their own end and send it to Access Bank. You get, so it's the whole idea of API is you want to send information or get information from a particular server or particular system. And for you to do that is through endpoints. And for you to access that endpoint, you need to be authenticated. And you can be authenticated through maybe your username and password or your access token. Okay.
Thank you very much.
You've answered my question too. That's what I want to ask.
Okay. Thank you.
Okay. Thank you very much, Kenichi. So with that in place, we're talking about where were we? Okay, common data formats and handling. Okay, so they said the three most common file formats we're working as data scientists are CSV, JSON, HTML, and such. But that is not limited to that. Definitely, this is when you're working with structured data, like data in tabular forms, and you want to do stuff like that, or physically a structured data. But when you work with unstructured data, maybe when you're going deep into maybe deep learning, pictures, sounds, stuff like that. So, the two most common files you definitely see are going to be CSV, JSON, and HTML files. So let's look at them deeper. So CSV means comma separated values, but that comma comma does not necessarily mean that all the CSV files are always comma separated. We can create a CSV file now. This CSV file is just a plain text file that has a delimiter. A delimiter is something that separates each unit or each element of the file. So let's just create a CSV file here from our notebook. I think we can do that. Yeah, plain text. So this is plain text file. So we can say name. We can use comma, or let's use space. So it don't be comma separated, just to show you and stuff. Age. Go down. Say Jacob. 23. Jane 21, Peter 30. I hope there's no Jane, Jacob, or Peter in this class. I'm sorry if there's any. I'm just making an example. And let's say Rita. Let's see, 18. So with this, I'm going to rename this file to be data.csv. Okay, so from here now, okay, this the example here, the guy used a comma to separate the values, and quotes to represent the strings. So supposed to use strings, supposed to represent them with quotes. Yeah. So yeah. So you can use tabs, you can use space, you can use any delimiter that you want to use, but you have to specify it when you're reading the file. So here, after I created the file, we read the file as a data frame using pandas. Pandas is a Python library that aids data management from reading, manipulation, and stuff with this data. So here he read in the data, the parameters that it takes are the data itself, the full name and its extension, the delimiter. Here he used a comma. In our case, we use a space, and the quote character there is like telling telling pandas that it should take cognizance of the text as quotes, because when you're trying to input it, those quotes should be, if not, Python might run into error, but that's the default. So that's just telling that the strings are quotes and should take cognizance of that. So okay, let's read in our own data that we did. So let's save this. That's saved. Okay. So come to our here. Okay. So if we come to our we have to import pandas first. We have to import pandas as PD to make it short. Then our data frame, which is df, which we want to read now, will be pd.read. So with CSV, set it to show order with CSV. So call it data.csv delimiter right? That's a spell here. Equals to space quotes character. Let's quotes car. Okay, quotes car equals to 1. So if we should do pd.read.head. As you can see now, the data that we created with spaces is being read now as like a tabular form. So one confusion that people get, a CSV file is not an Excel file. An Excel file is created in an Excel spreadsheet. So and the format of Excel files are mostly binary. They are binary files. But a CSV file is a plain text file, just as we created here. It's plain text. It has converted because we have read it now as a data frame. But when we're creating it, we created it with spaces. And here we indicated that a delimiter that we're using is space. So imagine we used maybe a dot. We just have to specify that what is separating each content is a dot. So I don't know if you get me. And the what's it called? The strings are not in quotes. So stuff like that. So because this might come very handy, because there are sometimes some numbers, and some numbers are in string format. I want to keep it like that. So this is just to tell you that, okay, see, these ones are string, and stuff like that. So and also just for you to know that pandas reads other files other than CSV. It reads Excel files. You can check that out. It reads a lot of files actually. So you can check that out on your own. Then also JSON, which is also known as a JavaScript orientation object notation. So this comes to place like you saw in that CSV files. Everything was just being separated by commas and stuff like that. But when the complexity is getting maybe way than getting way when the complexity is increased, like we have let's check if we could okay, like you can see here, I don't know if you can see, this is a film and it has a list of different APIs for different films. I don't know if you can see that. So we're having a list inside the value. Like all these ones are just name value, but this one now we have a key value. Now we're having key and a list of values. So the complexity is increasing. Inside those list of values, you can also have another key, or even have a dictionary inside. So when the complexity is getting higher, the JSON will be the best data format to resort to, as you can see. So that's why most APIs push out JSON, not because of the complexity of the data. So where were we? Okay. So like you said, a number of different types can be presented. We have numbers, which are always represented as floating points, strings, true or false, list, and dictionaries. So when the complexity is like, see this one now, this is a key. This is a key with a value, another value that is in a list. So we have like a list of lists as a value. So the complexity is getting higher. So in this kind of cases, JSON will be a good good data format to resort to. Okay. Also, we also have a Python library that can help us interact with like JSON. It's an inbuilt Python library. It's called import JSON. Okay, so let's get this API. This data that we got here. Let's copy this, right? And let's try to read it in. So let's do response. It's going to be equals to request dot get request dot get. So we're trying to get that. Okay, and okay, so let's try to load it. So let's say print JSON downloads. I think it's loads. Okay, loads response. Response dot content. So trying to get the content, which is the HTML file in this case. So okay, as you can see now, this is the same thing that we got from this place, count 82 next previously and stuff like that. So we can actually interface with this data from Python using this library. As you can see, where's that my guy? Luke Skywalker is here. So everything is still as it is. So we can also get this as this. Also, if you want to, maybe let's say you're working on a Python environment and maybe you want to shift, push a dictionary, because I definitely know you. I believe that you know data Python structure. Lists are created like this. Dictionaries are created like dictionary and sets are created like this. But dictionary has key pair values. So, for example, let's say we create a dictionary. Let's just call dictionary one. What will I do now? Let's say food. Okay, let's say food. let's call food, let's call bread, which is a key, and the value is true, and the next key, Gary, let's call this false. So this is a dictionary. If you should check it, this is a dictionary type, tick one, dictionary. And I want to push this to the JSON file. The JSON file library has what we call JSON.dumps. That's like you're trying to convert it to a JSON file. So we just do JSON data equals to JSON.dumps, and you put in your dictionary one. So let's call JSON data. So this now it's a JSON file. Let's see if bring like that JSON data. It's a JSON data, but it's been expressed as a string because everything is it's been saved as
called the JSON string.
Yeah. So with this, you can also push your data back to JSON and stuff like that. So you can interact with it using this Python inbuilt JSON library. Okay. Next, we move into okay. This was from the GitHub API that it got. So you can see the login was the guy's username, his ID, stuff like that. It linked to his image, stuff like that. So you can try this when you've set up your GitHub account, and can try this out. Okay, so this is what we did just now, passing JSON in Python. Passing, the word passing just means trying to put a sequence of data into a system that makes it understandable. Like I put it like that. So we're trying to pass JSON file in Python. So we're trying to make the JSON file in a format that Python will understand. So you use JSON library to do this. Like we did loads, we did dumps. So write JSON to file. So you can play around all this. So next we have is there any question so far? Okay. So I didn't hear you.
Hello, sir.
Yes.
Please, in the course of the lecture, I had a network breakage, so I missed some parts. I don't know if there's any room for me to access the lecture after the class.
Yes.
I'll venture watching it after.
I believe it's recorded.
Yeah, the videos are recorded and then they will be posted.
All right, thank you.
Yeah. Okay, so just before you continue, Brain. So I wanted to say, if you go back to your your code.
Okay.
So I hope everyone knows the reason why JSON might just be a very good way of retrieving data from say an endpoint or from an endpoint. Does anyone want to tell us why JSON might just be a very good way of getting data from an endpoint? Okay, Jerry.
He allows for
okay, one person, please. I think Jerry has spoken before. I want someone new. Okay, let Ayodele speak.
So, my understanding about JSON data, what I noticed there is it always comes with key and pair values. So,
okay.
in case you want to use a value that is maybe in a block, you can just quickly point to the key and it will bring out the value that is underneath. So, it is very easy to get every value that is being assigned to key. That is why I believe JSON is very good to get data from an endpoint.
Okay, thank you. Does anyone have any objection?
I have a question.
Okay, nice. Sure.
So yeah, so what's the difference between using JSON and Beautiful Soup?
JSON
I've
and
never used
Beautiful
JSON.
Soup. Okay, so there's a big difference between Beautiful Soup and JSON. JSON is just another way of representing, or another way of structuring your data. You understand? Now, if you remember, we're talking about JSON is in the, if you're looking at the league of data types, right? You're talking about JSON, HTML, XML, right? These are the leagues of data type, right? So JSON, you can retrieve data as a JSON, right? You can retrieve data as HTML. You can retrieve data from an endpoint as XML. Beautiful Soup is just a Python library that helps you arrange your HTML file, or do some quick search on your HTML file. Let's say, for instance, HTML contains is just a bunch of HTML tags, your A for strings, your div, and all the rest of it, and then you pass in that your raw HTML content that you have done with your request.get, right? You pass it into Beautiful Soup. Beautiful Soup, you can use it to arrange that content. There's a Beautiful Soup, I think it's Prettify. Yes, so Prettify arranges it for you if you want to see it in an orderly manner. And then let's say you want to get all the links that is in that HTML file. You just look for the tag A. So Beautiful Soup is just a way of manipulating HTML files. Do you understand? So Beautiful Soup and JSON, they are in no way, you can't really bring them together. When you're looking for something to compare with JSON, yeah, it's XML. XML is a different format. So XML, go back to your code. Okay, yeah, you're on it. Your code, yeah. So if you're going to have an XML file, right? So if you're going to create an XML file that is similar to that dict that you have, right? If it is going to be XML, what you would have instead is, so Brain, put your greater than sign, the arrow, the bracket kind of greater than sign. I don't know what the name is.
I didn't get it.
Okay, maybe I'll just write it on the chat so that everyone will see it. I'll write it on the chat. Okay, so so I'm going to write bread. I'll send it, so you just copy it and paste it, Brain.
Okay.
I'm sorry, I think bread. So bread is true, right? True. Bread. Then you have a closing tag, bread, right? And then you have another one called Gary. And Gary is false. Right? Gary. So check the message.
Okay. Okay. This, right?
Yes. So you can just separate, go to the next line from Gary. Okay. So that's from the beginning of Gary, So just to make it look nicer. Gary, the tag for Gary. The tag for Gary. Yeah. So this is what your XML will look like. Normally, you might have a starting tag called root, and then it ends with root when you're dealing with XML. But this is what it is basically. So your key will be the name of the tag. Then the value will be in between the beginning of bread and the end of bread, right? So just like you have in JSON and then dictionaries, where you can have, say, a dictionary inside a dictionary, you can have a tag inside of a tag in XML, right? But XMLs are not too easy to manipulate. compared to dictionaries, because with dictionaries you can just, yeah, you can do dots. So you can just say maybe bread. If you had another type, you can do bread dot something and to give you the value. But from my experience, right, I'd rather stick to JSON than XML. XMLs can be really hard to manipulate sometimes when it gets really complex. So is there any question? Any other question?
Okay, let me add to what he said. About the difference between JSON and Beautiful Soup. Like he said, JSON are just data types, like data structures in which you save data, just like we have Excel, we have CSV. Beautiful Soup is a Python library that passes this HTML files. Like I said, passing is just a way to make this thing understandable. Like definitely, if you saw our content earlier on, look at how messy it was. You can't really understand this, but I will show you a quick example of how Beautiful Soup will make this thing a bit arranged in a way that we can actually understand it. But let's just touch XML first. Okay, let me just show you a quick example. I did a scraping on COVID-19 data on Wordometer. So I don't know if you can see my screen. This was the request for the data. This was the page. It was successful. This was the content. Look at how it was. But when I imported Beautiful Soup and Quantifier, could give me this format in which like normal HTML format look like. So with this now in place, you can see coronavirus update live and just like. So with this now we can start. Okay, this is like a the title tag. We can start extracting what we want. So this is where Beautiful Soup comes in place. With this and this you had initially, now searching for data is it will be quite difficult here than it to be here, because this has passed the HTML file into something that we can understand, and from here we can extract our data from. I don't know if I'm making sense. So
yeah. I think I get
arranged. So it's arranged. So let's go back to our slides. Let's not be ahead of ourselves a bit. So like HTML and XML. HTML is like the content that you see on the web page. For example, if we go to About Us, and we should go to our developer. I think it's control. If you can see, this is the HTML. Can you see the tab that just came up?
Yes.
Yeah, you can see the HTML file. So this is what we're trying to get now. Like when we're trying to work with HTML file, we're trying to get this content. Like you can see, if I click a section, it shows that part of the page. If I come here and inspect About Us, where About Us is, so stuff like this. So this is what we want to just get when we're working with HTML file, this content, because this is the whole content of the page. The pictures, where they are located, look at the assets, femi.jpg, so stuff like that. So this is like the HTML file that we're trying to work with if we are working on this web page. So that's what we're trying to do here. So this is the HTML. XML is it's more scan to configuration. Like sometimes in HTML you can open it and don't close it and things will still work like that. But XML, you have to be like, you have to close every opening tag. You have to watch case. Your case is very case sensitive and such like that. So HTML is more of like presentation of what the presentation of data on the web page. XML is more of like trying to transfer data. So you can do more research on that. So that just heads up. So like I said, like we mentioned earlier, Beautiful Soup is that library that helps us get that data. So Beautiful Soup help us pass the HTML document first to our script or our notebook. Then from there we can start extracting what you want to get. Like for that example, I was able to, if you know how that Wordometer site, it's just Wordometer. Let me see, Wordometer. Where is that? Wordometer. COVID-19. So it. So there are so many there's many irrelevant things that might be on the side, such as ads and stuff like that, like all these shoes. Now we don't need all this data. So it's first of all pass this, then we can start knowing what to extract. So this was what I wanted to extract, this table here into a data frame. So with Beautiful Soup, close this. Beautiful Soup. At the end of the day, this is what we got after the operations and everything. We could get the table back. So this is why it's quite intuitive that you know this. Like the other passers, but Beautiful Soup, I think, is one of the best out there. So I think that's okay. So here, first of all, you create a root object from Beautiful Soup to get the respond.content. So we're trying to get the HTML file here. So, and here now we're trying to, like I said, the parsers help you to understand the page. So after we have the root objects, now we're trying to find a section, and find section with an ID schedule. When you're working with HTML, we have what we call classes and ID. Classes and ID are like attributes to a tag that you're trying to use. So when you're trying to find, maybe in this document, I've not opened this HTML file, but I can use maybe the COVID-19 to explain better. When you open the file, there are different sections, there are different section tags. Can you just open it so we understand what they did here? I believe there are different section tags. So, okay. No. There are different section tags. Let's close this. I feel that documentation is not there again. So I think they have updated the link. So if you should take a look at this HTML file, for example, you can see there's a body tag, and this body tag has different div, which are different sections, and they have different classes names and stuff like that. So from that work they were trying to do, they had different section tag, and they were trying to get the one with an ID schedule. So from that, they were trying to extract the table and find the value T-body, which I believe is like definitely going to be the role. The file is not opening, if not would have seen it, and find all the A tags, which are like link tags, stuff like that. So let me show you from the COVID-19 work I did. So here, this was my table, and I was finding the tables, like which was that table which I showed you. So from this table, the attributes, the ID here was main table countries today. That's what they saved it with. So I was using this to get all the tables I could get. And if you look at this, it got all the rows and tables in one line, which is not what we wanted. So with that, I had to find all the rows and kind of like append it, like get the rows and append, make it to the next line, split and stuff like that. So that's what I did here. So with this, you're able to find certain tags and certain classes and IDs, or certain features with certain classes and IDs in that HTML file. So that's why the Beautiful Soup also pass that HTML file, so we can find stuff like this. So maybe you're looking for a table or looking for a picture. For example, okay, this imagine you wanted to get this famous picture from this our AI this page. Definitely we have to inspect it. So we'll come here, look at the class name, ID, AMP, HTML, field stuff. So this is the class that we use to find the image. I don't know if you're getting me. So this is the class we use to find the image to maybe extract it. So if you can look at the next image, definitely to have its own class. Okay, all of them had the same classes. So all of them had the same classes. So if you want to extract these images, you use these classes as a reference to find the image tag. Because definitely there might be different images. The icon might be an image and stuff like that. So what separates all these images is also an image. So if you say you want to just extract all the image, maybe you might get this, you might get this also, but you want to extract the ones that you want. So how to make that specificity is using the class or the ID of that certain feature that you want to extract. Are you guys with me?
Yes.
Okay. So I hope that's clear. So you can also play around. You can also look at the documentation of what you need to script. And a good tip also, if you want to go into maybe you just have to have an overview of what the HTML looks like, the tags, which is quite easy, the A tags, the table tags, and stuff like that. So you know what you want to script, where it is, and what format it will be under. So I think so that's that with the 3-5 formats that we've looked at. So the next content on. Okay.
I think you have some questions on the messages.
Oh, okay. I'm not seeing that.
I know Habib sent a message.
Okay.
And I am Billy.
Okay.
And
okay. Okay. So he said, he said that we use the SRC to get each image. No, we use the image tag. If you look at that RC is like source, like the path to the image. So if you look at let's go back. So let's inspect. So if you look at this now, you see that the tag here is img. This is the image tag. This is the image tag img. So we'll use the image tag first of all as our reference, then use the class to search for that image. This source, this SRC here, is just showing you the like the path to where the picture is, which is the guys the person that designed this was in assets/images/the picture. So this is like the source, the part of the image. So we don't use that. We use the image, this img, which is the image tag. And
yeah, I think I know what Ayodele is trying to say. So just like Brain said, the first step is to get the particular line of code that is for the image that you are looking for. So once you have that line of code, I don't know if with Beautiful Soup, you can access the content of the SRC or the SRC variable, or whatever it's called here. Then you can use that to pick that path. Let's say, for instance, you want to know the URLs to all the images on the website, or the URL to that particular image. Then you can then use that SRC to now find the particular image. If Beautiful Soup doesn't have a way for you to just quickly pick the content of SRC, then you can just use your regular expression once you know the particular IMG tag that has the image. You get. Okay, I think I got some people more confused. Okay, let's just go on. I don't know.
Okay. What you analyze the other time in scripting data, is it the same as we are scripting from keywords on Twitter? I don't really understand the question. What you analyze the other time in scripting data, is it the same way scripting data from keywords on Twitter?
Okay, so
do you understand the question?
Okay, I want to respond. So I haven't actually scraped data from Twitter yet, but I know from the few people who have contacted me and wanted to scrape data from Twitter, you'll need access to Twitter. That's Twitter's endpoint, their APIs. Yeah, so it's not web scraping.
Yeah.
Do you understand? You are collecting data from Twitter through their APIs. Do you understand? So once you have access to Twitter APIs, you send a request in the format Twitter APIs want. So once you send your request, Twitter returns the data that you need for whatever project that you need to run. You understand? And I know that for you to get Twitter's data, you need to properly state the reasons why you want to use that data, because it's quite sensitive for you to just pick data from Twitter.
Yeah. I think the library is a Python library that also does that quickly. I think it's Tweepy also. Tweepy, yeah.
Yeah.
Tweepy, yeah. So this is it. So you used to access to API, but you have to first of all go for a developer account to do that. So it's not web scraping, it's they provided their API for you. Okay. So I believe we can move on. Regular expression and passing. Okay. So first question, what is the regular expression? They are not specifically for Python. Like it's not like they are general like sequence of symbols that try to search for patterns in text. So there are regular expressions in C++, there are regular expressions in Python. So they are not just unique to Python, I see. So for Python, we have an inbuilt library, a module that we can use to do our regular expression operations known as RE, definitely regular expressions. So so sometimes you want to search for patterns in your data, like Nancy said, like your whether it's CSV files, web pages, and stuff like that. They want to search for patterns. This is where regular expression comes into place. So this just you don't need to pip install it. You just import it. It's inbuilt. So the first thing that they did here was to search for data science in a piece of text, and we could try this. Try this out. So okay. So let's try this. Okay, so let's see, data is the new oil. Data is the new oil. Okay, let's just make everything lowercase first. Data is the new oil. Data science is the sexiest job in the 21st century. Okay. So these are texts that I want to work with. So let's say we are trying to look for a match for data here now. So the library provides a method called search. So we can search for what we need. So let's just say results equals to re search, right? Search data text. Okay. So I know maybe there might be a question on this R. So this R is trying to inhibit the Python notion of escape functions, for example, and just take it as a whole string. So for example, let me just give you a quick example of what this means. For example, let's say we have a string, hello, I think this is backslash now, hello world. We should print, okay, it's the other way around, hello world, or it's backslash now. Can you see? It's backslash now, the hello world, escape function, backslash n. test.
You called me brain.
Okay. The escape function is in / not forward. Okay. Let's do this.
Yeah, that's it.
Okay. Okay. So if you look at this now, hello world now, this escape n made the word to go to the next line. If you did like this now, made it go to the next line. If you do something like tab, it pushes it. So regular expression has a lot of slash in it, and with that in place, if we are using if we don't initiate this arrow to know that the stuff in this string is a regular expression, we might start having stuff like this. /n in regular expression might mean something else, but in Python /n means push the words after the n to the next line. So that's why this R is here, to make sure that the data, it takes cognizance that the data in this quote is a regular expression. I don't know if that is clear. So there are, this is like escape from escape. There's a word for it. Escape expressions. Yeah. So they're used to work with text and stuff like that. So this is why we have this arrow here. Okay. So so if you should print the match, the results dot start. So this shows us the index in which data was. So this shows us that is at index 1. This started at index 1, 0. Sorry, you know, from Python we count from 0. So this shows us that I started from index 0. That's why we have 0 here. So regular expressions can help us search for stuffs like this in our data.
Sorry to interrupt, but there are two data there. So why is it just picking one?
Okay. So I wanted to say that, I knew someone would say that. So now that function dot search, it brings the first item that comes up in the search, in the regular expression search. You understand? It does not give you everything. There is another function that will give you all the occurrences of data in the string. Do you understand? So now, brain, if you remove the first data and put it at the end. So if you remove the first data, you can decide to put it at the end or anywhere, or you can just search again.
I've removed it, so it's at index 16 now.
So run the code. Now you see now it's 16 because it's going to the next, the first one that it sees. The first one that it sees after we've removed that one is this data. You understand? So you will still see as brain goes on that there's a function to retrieve all the occurrences of data in the string.
Okay, thank you very much. So we also have another method called match. So match searches for if this we're looking for is at the beginning of the sentence or the text file. For example, we could see that when we remove data, okay, let's use this. When we remove data initially and use search showed that it was on 16. So let's try match. Let's say result 2 equals to re.match. re.match, and let's call the data in again. R data, right? We're searching for it in text. So if we should run this and print result 2, results 2. Okay, there's no object. Okay, there's no attributes for that. Okay, so if you should print results.
There's no start. There's no start in match. Just print results. 2.
Print result 2. So as you can see now, it's showing none because it checked the beginning of the text and found that there was no data in front of it. We should put data here now and run this again. You see now it's telling us that it spanned from 0 to 4. So this is 0, 1, 2, 3, 4. So it's showing us the match for it at the beginning of the text. So that's quite the difference between match and search. Match search the beginning of your text for the specific data it's trying to query. If it doesn't see it at the beginning, it goes none. But if it's at the beginning, it tells you the length and the span of that. So maybe this could be used maybe if you're trying to do maybe password or something like that, and you want it to be like the text to match, the characters to match as at the way. Maybe you could do something like that. But if you want to just search the whole document for maybe a occurrence of a word or something, search is your best bet. So, okay, look at it here. It said it finds the first occurrence of the string. So that's the difference between match and search. So it finds if start of the text matches, finds the first match or none. So it finds the first match. So that's why the first match, when I removed the data initially, the first match was at index 16. So that's the difference. Search searches through the whole text file. So we also have find iterable, which is the method to print out, like you said, the different occurrence that we had. It didn't show us, right? So we have we have another a method for that. So okay, so let's do that. So see for results in r dot find I think it's itra. So we're looking for data, right, in text for our in that. So to print results, let's start. So as you can see now, it shows us the two data where they started from. So this is index 0, which is the first one. And if you should count the index, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So it shows us the various indexes or locations where data was found and when it started from. So with that in mind, we can also try to check all the occurrence, like to know, maybe want to just have a picture of it. You can do something like find all. So we'll do all will be equals to all occurrences. Occurrences equals to re dot find all. Say hyphen. Okay, find all r data text. So let's run first, and let's print all occurrences. Come on. So as you can see, it came out twice. So maybe we could check the length and stuff to know, okay, this thing came out how many times and stuff like that. So this one found all the data that was in the text, which was 2. Okay. Okay, I think that's what we did. Find all the matches. Okay, and also sometimes we might want to use compile if, for example, we want to save a certain pattern and we want to be using that pattern always. Like if you can see from here, we want to call it again. You use r which is r.data, which is the pattern, and we still call the text again. But we could compile that and save it. So we could say something like let's say, okay, this is regex could save it. So we use compile. Let's use pattern better for pattern. Compile this. So compiling data, which is our pattern, right? So now all we need to do now is to come and see pattern dot find. Let's use our find all, which we just used here to get all occurrences from the text. So you can see. So instead of writing this array again, we have already saved it as a pattern. So we'll just come again. You can see pattern dot search, which we used previously, up search the text. So shows us 0.4, which was the same thing we got when we did search initially. So we have saved the pattern. So instead of us rewriting it, we just use the pattern that we saved, because sometimes it can get more complex and want to just can save different patterns and use different patterns on that same text rather than rewriting it. So trying to make things easier. So like I said, yeah, you can use compiled on search, find all, find iterables, and the rest. Okay. Moving forward, definitely we could use if you're looking for a text, you can use your Command Shift F to find on the document. But what makes regular expressions powerful is the ability to match and combine different sequence of characters together. So here, first of all, I'll tell you it's not a thing to cram. Regular expressions can be quite confusing. The syntax is not something that you will just grab at first. When I'm working with regular expressions, I normally test my regular expressions on this platform, regexarrow.com. So you can see what's happening here. So let me share this link in the chat, so you can check it out. So you can check what you're trying to do. This quite regular expressions are quite powerful. For example, when I started with data science and I enrolled on the competition Titanic data set. I don't know, maybe if any of you have worked on it and stuff like that. So it was for hackathon and stuff. So we're trying so many things to boost our models, and people were looking for different models. We were doing different feature engineering and stuff like that. But someone told me that I should try and read up regular expression and look at the names, if I can get patterns. I was like, well, how will I use something I've not tried before? I said, okay. I went to Google, check regular expressions, and I started getting understanding. And what I could do, regular expression for that competition, was to, from the names, like they had things like Mr., Madam, Mademoiselle, Miss, and stuff like that. Some French version of Mademoiselle, Miss, and stuff like that, Spanish version. So what I could do, I was able to get those patterns, like, okay, I know all these are feminine, and make it one class. I don't know if you get. So all the names I could, okay, I shifted Mr. John. I know that Mr. was a male. Mademoiselle, this was a female. So with that alone, now I could do more feature engineering, get more feature out of that data that I had. Because people were just looking at the name. What do you want to use name to predict? Just remove the name from the data set. But with regular expressions now, I was able to understand that, okay, I could get certain features from these. Like get the classes of it. Definitely, you know that Mrs. and Miss are not the same class. Mrs. is a married woman. Miss is a young lady. So in the case of the Titanic, a young lady will move faster than an older woman. I'm just talking out of the box, but there are some patterns that could be surrounded around those kind of things. So regular expression is really powerful when you're working with text data. So it's not something you should cram. Something that if you want to work, you go, you check it out. There's some check out, know what to do. Google. Definitely the patterns are not something that you want to cram. So like before, if you want to match a character, you use the character, which we have been doing since, trying to match data and stuff like that. So also, okay, also if we want to match set of characters together. We use a what's it called, square brackets to group them together. So let's say, okay, we change our data. Let's say we change our data here. Let me close this chat section. Okay, let's say we put this as capital letter D. Coming. Okay, let's say we change this D to capital letter D. What do you think is going to happen? Are we going to have, if we search, if you match, are we going to have any results? If we have this as D, if we should match this now, do you think we're going to have any results? Okay, as you can see, said none, to tell you that it's quite sensitive, to tell you that data with a small letter d and data with a big letter D isn't the same thing. I'm coming, excuse me. So that shows that they're not the same thing. So in this case, definitely imagine that we had a lot of text data and we don't know how the case format was and stuff like that. I want to search for data. So definitely we want to take cognizance of both the capital letter D and the small letter d. So we'll do something like match, come here, match, put this in, want to search this, so put both the capital letter D and the small letter d. And if we run this, as you can see, give us back. So we have combined, just as we have combined both two this thing. So it's searching for both the data with a capital letter D and data with a small letter d, which is quite reasonable, because when you're writing, if you have like a million lines of text file, we wouldn't want to use our eye to scan if all of them are small letter D. Definitely want both the one that is capital letter D and small letter d. So that's where this comes handy. So if we want to match digits, okay, first of all, we can remove we can also remove except. So we remove we can remove using the caret sign. So all this, you can come here and you can play with it to really understand what is going on behind the hood. So you can check, you can come to regex.r and play around these regular expressions. So
sorry, I wanted to ask Brain. I haven't used regexr, but if you go back to the page, sorry, I wanted to ask, so can we change the language? I'm saying that it's on JavaScript at the top. Does that mean that it's for JavaScript?
No, like I said, like this okay, let's try some. I don't believe that has to do with anything.
Oh, okay. I was just curious.
No, it doesn't have to do with it. For example, let's try an expression here. Plus, okay. So let's search. Let's search for. Okay, let's search for below, or what's common here. Expressions, or you okay, let me just add to this file. Let's say data. So with this, now this is searching for A to Z. So it's searching for all the alphabet numerics. So if we should do A to B, so you could just play around. The syntax it's not something that you just know offhand, but with the basic concept that you know, like numbers 0 to 10, like this one now searches for A to Z, and 0 to 9. So you definitely search for all the alphanumerics. So if we should take this to regex and let's paste it here. Let's paste it here.
The equal to sign, is it supposed to be there?
See, I missed equal to.
There's an equal to sign, yeah.
Yeah, it's supposed to be there. It's there. Let's see. /w. Okay. /w. Copy /w. /w. Okay. 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 So I missed the what's it called, the curly braces and the square. So as you can see now from this document here, it says matches all alphanumerics. So from here now you can see that it matches everything about the symbols except the symbols, the dot, and so if we should add anything that has to we should add 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You're going to match everything in the document. You get. So with this now we can actually test our regular expression. So if we should say okay 0 to 3, right? Let's see 0 to 3. Okay, let's come here 0 to 3.
So I think I think sometimes I'm having a feeling that this particular page works with JavaScript. I'm not sure, but can you try it on Python and let's see. Just try the same thing that's giving an issue because.
Okay, let's copy this. Okay, I can continue.
Copy this text. Copy this text and then try it on Python.
Okay. So let's call this text. Then copy. Reload. Okay. Okay. So we're searching for, we want to match everything now, right? Okay. So let's copy this regular expression. So, dot match. Dot match. And this regular expression. It's dot match.
You didn't add your text.
Yeah. Okay.
I really recommended the site that would also check out.
Match the text.
Let me see the code.
The R is not there, R that starts there. Okay. And there was a space.
And remove your space. All the
space, the space.
Remove the space.
After R. Okay.
No, your bracket isn't complete. Now see, now check.
Yeah.
Yeah.
So this was okay. Let's search. Search.
Use find all instead. There's something wrong with the regular expression. Go back to match any alphanumeric. White space. This is wrong somewhere. Let's move on. I'll correct it. Just continue. Go on. I'll correct it. I'll check it from my own end.
Okay. So so these are some of the expressions I can try. As I told you, it's something that takes you have to look up things because it's not something that you just have to just know offhand. So something that you have to look up. So these are some of the expressions to get for example, to match white spaces, maybe if you want to remove white spaces from text, and new characters. So matching repeated characters, I think we have done this when we did the capital letter D and small letter D. So we've done this. So now this is a regular expression that wants to match various, like for example, from the text that he used to practice this, he had something like data science and stuff like that. He wanted to match other subsequent words that has maybe a prefix, or no, a post a suffix of science to the word. Suffix is after the word. So okay, no, prefix, no, suffix of science, sorry, suffix of science, like after science. So I was trying to use a regular expression to get everything that has science next to it or something like that. So this was the regular expression he used.
Before you go on, let me now ask, go up. So I'm not really, to be honest, I'm not really cool with the. It's not, the regular expression is quite, it can go more detailed than this. Yeah. If you really need to understand it well, you have to have an idea of what each of the syntax in regular expression mean. So there's when we taught in the third cohort, that was in 2019, I think that was 2019. There was a notebook that we came up with for regular expression to just help everyone understand regular expression, which I'll share, right? Let me share it now so that Brain, you can just put it up on your screen.
Okay.
So I would want everyone to go through it. I've also put the resources on Google Classroom. So I named that bit extra resources. So the platform you're using for the regex is actually for Python.
JavaScript.
It's for JavaScript. Ayodele made the clarification.
Yeah.
There's a URL that Ayodele put. I can just reshare it. I think he called it Py. Okay. No, he called it PyTrex or something like that.
No,
okay, this is another one.
Yeah.
Okay,
this one has Python.
Okay, this one is for Python. Okay, there was another one he also posted too, which everyone should check out. Pytext.org. Oh, sorry. I'm writing Python as well. Sorry. Okay. Okay, he puts, okay, yeah. So these are also places where you can check out your regular expression stuff. So I posted, I sent a link to the group where you can all check, because if you're using just the slides, it might get a bit confusing, to be honest, right? You then ask questions like, what is the use of the /s? What's the use of the /w? What is the use of the /d? You understand? So
okay, the /w is for like you're trying to get the words, /s is like you're trying to get the space, /g is like trying to get the digits.
Yeah, exactly. So can you go to check the message? There's a link I put there.
Okay.
So regular expression can be really, really cool, honestly. If you know how to use it, you can manipulate it in any form you want to.
Yeah, and the issue that most times people just get is that it's not Python, like Python syntax. So it's like you're trying to learn it like on your own. Like it's like a whole new language on its own. Yeah.
Okay,
Wow.
so this is a more detailed notebook on how you can learn regular expressions. You understand? So you'd see it gives explanation of everything, and then there is an example. We'll put down examples that you can use to understand everything. So I ran these examples on a notebook. I don't know if we still have the time. We have about 8 minutes to go, right? I don't know how we are going to do it. Or I don't know. So do I leave it for everyone to go through, or should they go through it in the next 5 minutes? Maybe let's just see what we can do. I need everyone to vote. Does everyone want to take it as a challenge to go through, or should we just go through it in the next few minutes and see wherever we stop, we stop?
Let's
Anyone?
go through it. Let's
Okay.
go through it.
Okay. So, Brain, can you?
Yeah.
Can I share my screen?
Okay. I'll stop sharing now.
So I'll try and move fast, yeah, so that at the beginning, the beginning of the whole stuff, I'll try to be slow so I get the basics. But towards the end, I might be very fast, so we can meet up with time.
Okay, I've stopped sharing.
Okay, nice, thanks. Okay, so can you see my screen?
Yes.
Yes, sir.
Okay, so like Brain has already said, he has done all the intro. So the essence of regular expression is that we want to find patterns in a text, in a string, you understand. We want to be able to write regular expressions that will be able to pick the exact thing we're looking for, you understand. So let's say, for instance, you are given a bunch of data, right, that is very, very dirty. And you need to maybe either remove some specific things or you want to filter out some specific things. You can just write a regular expression that will be able to pick out these things or pinpoint to the areas where these things exist and extract them for you. You understand? So this is a Jupyter notebook on GitHub. I can't edit it, but I have another notebook where I can just run the codes for you to see. So there's a detailed explanation that we know, as Brain had said, the /d means that you are trying to find characters between 0 and 9, right? Where d is the digit. And it's called a meta character because meta characters are not specific, right? It's a more generalized form of is a general character. So there's something called literal character and meta characters. Literal characters are kind of specific. They always occur in that format. Meta characters can vary. So a number can either be 1, 2, 3, 4, 5, 6, 0, you understand? But a literal character, kine in small letters is always kine in small letters, you understand? There's no deviation from, except if you want to now say it can either be kine capital letter K or small letter K, right? So now, say for instance, you want to match a particular format of data, of number, right? Let's say it's a phone number. We'll see a more complex phone number, or in case we don't finish, there's a more complex form of phone numbers and how you can use regular expressions to select, to find them in a bunch of text here, which is below. So, but let's say you want to find all the numbers that are in this format, the three number first, then followed by 2 number, then 4, you get. What you just need to do is you do your /d/d/d/d, meaning that you have 3 numbers, then hyphen /d/d. So now this is supposed to be just 2/d's, yeah, instead of the 3. It is an error. Then you have 4. There's also a simpler way of doing this. Instead of doing /d/d/d/d, you can just do /d and then your curly braces, right? And then you put the number 4, meaning that it's occurring 4 times, right? So an example of this is, let's say we have a line that contains all this, yeah? And then we want to use regex, right? To return all the digits that exist here. So the way we do this is we use the /d and plus, meaning that the plus means that you want to find all the occurrences in the next text and all the occurrences in this string, right? You want to keep moving down the string. And when you do your reject.findAll, it will return all the numbers that exist here, and it eliminates all the spaces, the January, Kali, and the rest, to bring out only the numbers that exist here, right? And if we run this, I have a notebook here. Yeah, okay, so okay, I was trying to see how I could arrange it here, but there wasn't so much time. So, but let's, just like you had in the other notebook, when you have your import tree, you have this your string, right? And then your regex is this, right? So you can put your arrow here. Well, not necessary in this case though. So you do your find all. When you do your find all, you find out that it returns all the numbers here. So the first number that it finds is what? 3, right? Next number it finds is your 07. The next number it finds is your 57, and so on and so forth till the last number, which is 2. So in as much as 2 is embedded, is a part of SSH, is SSH2, yeah? It picks out just 2 in this whole text, right? So that's that. Then let's move on. The dot means any character, and the hash star rather means 0 or more characters, right? So when you combine the dot and the star, it means that you want to find it's more or less, it's like, would I call it, is it a wildcard? It's more or less, yeah, it's a wildcard. So you want to search every occurrence of or any occurrence of that particular, of anything that might exist so when I say wildcard, it's more or less like finding anything. So let's say you have things in your text, you have stores in curly braces, and then you put curly braces * curly braces. It means I want to find anything that has curly braces with anything inside that curly braces. And we'll see some examples as we go on, right? So, and also, when you have a regular expression, say rainbow dot star, it means that anything that begins with rainbow, right? So it could mean rainbow 1, 2, 3, it could mean rainbow KNH, it could mean, so whatever has the name rainbow first, it does not want to know whether it's rainbow only, but rainbow and something, it will pick it and then return that value to you. So let's say you have a bunch of data that is a string, and then in the string, let's say the user was trying to separate, maybe there's a nomenclature, and then they say, okay, just yesterday, I was with one of my supervisors, and then he has this nomenclature of putting the word paper underscore, the name of his paper. So paper underscore means that it is his own paper. So let's say he has a text where it's a bunch of text, and then the names of the papers are there, right? If you wanted to find all his papers in that bunch of text, or the names of all his papers in that bunch of text, all he just needs to do is write the word paper and then do this *#, and it will pick all the elements that have that word paper in the beginning, right? So, right.
Can I ask a question?
So now, oh, okay.
That rainbow, so how does it know maybe it's just picking the next 3-4 words? Because there could be 1,000,001 words in front of rainbow. Is it going to pick all that? Or is it going to stop at the next rainbow?
I didn't get it, sorry.
So you have rainbow dot asterisk. So it's supposed to pick anything rainbow and then whatever comes after rainbow. I'm saying, how does it know where to stop? So because I could have like 1,000,000 words after rainbow, how does it know where to stop?
Still regular expression. So you could make it say stop after a space. You could make it you could tell it stop. So this is just a simple example, yeah. So regular expression can be more detailed than this. You could tell it, okay, stop after a space, and you know what your space is, /s, yeah? You tell it stop after 2 spaces. You could tell it stop after a text. You could make it tell it stop after a dot. You get that kind of thing. So you'll define all these things in your regular expression, right?
Okay.
Yeah. Okay. So we'll see when we are below beneath this. There's a section called groupings. Yeah. So you can group the regular expressions together, and then we'll get there. Okay, I'm gone 2 minutes past my time. Let me see if I can spend 5 minutes. Okay, so single characters, of course, you know, D means you're matching between /D means it's characters between 0 and 9, /W means characters where W means word, yeah. So character A to Z, small letter A to Z, and then 0 to 9. Your /S means white space. Your dot means any character, whatever it may be. And then anytime you capitalize this means the opposite, yeah? I haven't really tried this capital before, yeah. So then you also have quantifiers. So quantifiers means how it's more or less like how to what extent do you want to perform this, yeah? So now star means you're matching 0 or more. Matches plus means matches 1 or more. So when we did the plus here, what was it? I think it was somewhere here. When we did the plus here, you're matching 1 or more of the occurrences of numbers, right? Question marks means question mark matches. So we are going to see what question mark does here. It's I think you will see it more in practical. Let's just go on. Then n matches all n values, min max. So the majority one that you might be working with, even in the assignments that you're going to do, is the plus star and the asterisk. And that doesn't mean that your hands are all your hands are tied together to work with just regular expressions. Some other people write some very complex Python functions to do the same thing that regular expressions do. But why waste your time when you can just use regular expressions? Yeah. Okay. So for example, /W means match the first 3 words. So remember I told you that you could do /D. So slash in curly braces D, yeah? So when you do this, it also means the same thing as this. So when we say, I just realized how interesting coding is, you just want to match the first 3 words, right? So it's going to match the first 3 words in all this text. And let's see where that works. Here. I'm not sure if I can write it. No. Okay, so okay, something is wrong. Okay, so okay, why is this different? Sorry, something is wrong. I think I'm explaining the wrong thing. Okay, so blah, 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 blah. Okay, so this one just returns all the words. So this is a different example. I was talking about something else here, and I was doing something else, right? So what I wanted to do, what was on the top of my mind is showing you how to bring just the first 3 words in in this string here. So the first 3 words is just every first 3 words. So in this first word, it's just realized, then ed, there's nothing, then after the split. Okay, so well, that's quite different from what the notebook is saying. The notebook is just telling you how can you return all the strings, all the words that are in this string. So it's returning it as a list. So let's even say, for instance, yeah, you want to work with just each of the elements in this string, right? Already you've used your regular expression to separate all of them, right? In an easy way. You can now say, okay, what is the first, or what is the third is in a list. So what you can ask yourself, what is the third word? You can just do 3, yeah? And it will bring out your how, right? Because it's 0 to 1, 0 to n, right? Python is from 0 to n. So it brings out how. So that's when you're using the regular expression to separate each of the text. Some other people could do split by space, yeah? So if you split this by space, it will also return a string of a list that contains all the text. When did he come in? So okay. So I wanted to do that. I hope I still remember the syntax for this. Yeah, let me try. So let me say, and say because what let's make a split space I think there's it here. Yeah, so you see, it returns the same thing that a regular expression will give us. So it depends on what. So this is just regular expression doing the same thing that your dot split will do, right? But if dot split will give you what this will do, then just go for your dot split. But when you now want to go a bit more complex here, then you can say write a custom regular expression for what you want to do. Okay, so where were we? Okay, so now this is where you use question marks. So question marks is it's also like a wildcard kind of thing. So you're saying it might exist, or if this exists or if it does not exist. That's the kind of thing it's trying to say. So if we look at the example that we are look at it here. So now color can be COLORS. Colors can be COLORS. Can also be COLOURS, right? So now you could write a regular expression that says this expression can either have a U or might not also have a U, right? So when you put the question mark just after the word, right, it's going to give you, it's going to work in such a way that it gives you every occurrence that exists with a U and does not exist with a U, right? And you see it down here, right? Okay, so this is what I was trying to do the other time. Yeah, so I was going faster than my shadows. So we've all seen this, right? Okay. So I think I have just 2 minutes left. I have 2 minutes left because the deep learning class is going to start just after this. So now let's see how the star works. So remember we said it's a wildcard. It searches anything, right? And we have this text, square brackets, Google, close square brackets, HTTP, blah, 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 comma, test, blah, blah, blah. Then there's an N and the rest of it here. And then we want to find all the occurrences, all the values that are within the square brackets. So we're expecting to see a list that contains square brackets with Google in it, square brackets with test in it, a square bracket with ITP in it, right? And we also said that we can use the star dot star as a wildcard. Now, if we go back to regular, go back to my notebook and we run the code, right? This is what it gives us, right? And some of you might say, why does it give us this? Say, look, it's like it's wrong. Just for the record, the reason why we have the /n, the slash before this, is just so that we know that, remember, this square bracket means something in it means something in regular expressions. It means your grouping, right? So the slash before it makes regular expression know that okay, this is not regular expression grouping. It's actually a text type. It's actually a character that exists in the string, right? So that's why we have the slash before the n. And the same thing, similar reason why you have a /n to do the next line and the rest of it, right? So okay, so when we do this, you notice that it gives us just 2 items in the list. So don't be confused that you are seeing 2 commas. It's just 2 items in this list because it returns the values as a string. So you see that this from here to here is a string, right? And then from here to here is a string. So what it's basically doing is that it's there's a next line here. Okay, so now let me even remove the next line. It's checking each line and then returning the contents that are between the first square bracket and the last square bracket. And if you check this one here now, you find out that the first square bracket is this. In this first line is this. The closing square bracket is actually this person here. So that's why it returns everything here, right? Right? And the next one would be this person to this person. So if I remove the next line here, right, you'll see that it returns everything as a string. It returns everything as a string, right? So so for those who think that it's not so I mean, we can just print this as a how do they do this thing again? Nice. For in results, yeah. Print okay, so you see, it's just 2 things. This is the first one, and this is the second one. So, but now, if you now want to make it more efficient, and you want to make it each of the elements, you want to make it the square bracket itself, not that it just jump in because the wildcard it just checks anything, right? Then you bring in this notation of the question mark. So you have the question mark here. So this dot star, they call it a greedy expression, right? Because it checks every occurrence, just goes in. But when you put the question mark there, it reduces or restricts it to getting the primary one that you're looking for, right? So just like we have here now, if we run, oh, sorry. Okay. So if we run this, yeah, all we just need to do is put a question mark in front of this. Yeah. When we run this, it gives us Google first, then gives us test, then gives us ITP. That's why if you run this person again, you find out that this is what it gives us. So now you now see the reason why you're having the http.google.com in the previous one, because it was speaking from here to here. But all we wanted was just Google. So having the question mark kind of fine-tunes it to give you just the ones you need. And it goes on and on like that. So we'll have to stop here because the next class will have to start. But what will happen is on Slack, if you have any issues with regular expression, please post the question on Slack or Google Classroom, and I'll answer the questions. Yeah. So it goes on and on, but this is a quite detailed notebook. Like I said, the notebook is on Google Classroom also. I've added it there, so you can go through it. Make sure you read these texts first, and then also read the comments to know what is happening before you run the codes. You understand? So you have a clear understanding of what is happening. And it's not much. Already we've done from the beginning down to here. So all you just need to do is go through positions, character classes, and then alternations. Oh, there's capturing groups. Okay, so it's not too much. And besides, it's not like it's an assignment. You're running the codes and understanding what happens. And if you understand this well, you have an idea of how to do the assignments. I've also put the assignments for the second week. I've already, at the beginning of the class, I said I will do it by Saturday, but I already have them on Google Classroom, so you can also start them if you have if you're able to. Submissions are, I think, 2 weeks from now, right? So I think that we'll call it a day.